Hyperparameter tuning is the process of finding the optimal set of hyperparameters for a machine learning model. Unlike parameters learned during training, hyperparameters are set before the training process begins. The tuning process involves systematically adjusting these hyperparameters, training the model with each new configuration, and evaluating its performance. This iterative cycle aims to find the settings that yield the best results. The goal is to find the sweet spot on the performance curve, where the model achieves its highest accuracy or lowest error. This optimal point represents the best balance between underfitting and overfitting. Grid search is a common tuning strategy where we define a grid of hyperparameter values. The model is then trained and evaluated for every possible combination on this grid. Random search, on the other hand, samples hyperparameter combinations randomly from a specified distribution. It often finds better models than grid search in the same amount of time, especially with many hyperparameters. Hyperparameters significantly influence whether a model underfits, meaning it's too simple to capture patterns, or overfits, meaning it's too complex and memorizes noise, performing poorly on new data. Tuning helps find the right complexity. Effective hyperparameter tuning is crucial for building robust and high-performing machine learning models, ensuring they generalize well to new, unseen data and deliver reliable predictions in real-world applications.